Hello everyone. Now I am going to explain the full header using two half header and one OR gate. In full header using two half header and one OR gate, we will design it in MULTISIM, and we will also write the VHDL code, that is for the structural modeling of full header using half header as a component. That means structural modeling of full header in VHDL using two half header and one OR gate. So this is the circuit for the full header using two half headers. This is the first half header and this is the second half header. So the external inputs A, B, C in for the full header are these three. So in the first half header, A and B as an input, and the sum output of the first half header will go as an A input of the second half header, and C in will go as a B input of the second half header. So therefore here in the sum 1, say a sum output which I am considering as S1, which will be A XOR B, and along with this C, here the sum output will be A XOR B XOR C. Now the carry out of the first half header is as an one of the input to the OR gate, and carry out of the second half header is another input to the OR gate. So therefore, as we know, the carry out of the first half header will be A and B, and carry out of the second half header is also A and B, but here A is A XOR B. So here C2 will be A XOR B and ended with C in. So here you will get A XOR B and C in, and here you will get A XOR B, and together if you do the Boolean expression, use the Boolean expression, then this final C out will be A and B, or B and C, or A and C, that is AB plus AC plus BC. So let us see how we can do this full header using two half header in MULTISIM. So this is the workbench of the MULTISIM. Okay, so here we are going to first design a first half header, and we know that the half header is one AND gate for the carry out, and one OR gate, XOR gate for the sum output. Okay, so this get common. This is your sum and carry. So here what we'll do is I'll make it as a single block. Here you see replace by subtract. So it becomes, I'll put it as half header. So it becomes a single block. That is your half header. So what we'll do is I'll connect wires. I'll connect wires. Where is the wire? Wires. us design again. Okay, so XOR gate, this is XOR gate, then 7408, that is your AND gate. So then input 1 input is get common, then that's where then another wire or this, and here is the sum output, here is the carry out. So now I will make it as a single element as half adder. So this becomes my half adder, this becomes my half adder. Okay. Okay. So let us do one thing, copy and paste another one. So this is my half adder 2. So as you see, the sum out is directly connected as another input and there will be a third input, this is my C input, and there will be one OR gate, 7 4 3 2. So here is the OR gate. So the carry out of the first as one of the input to this, and the carry out of the second half adder is another input of this, and this is my sum output. Okay, so this is final carry, this is your sum, and this is your A, B, C. So now we'll use the source digital source, and then another source and another source. So these are the source. Okay, suppose this is my A, this is my B, and this is my C, and we'll use the probe. So this is for sum output, and say this is for carry output. Okay, Now save it. Header using half header. Okay, now let us run it. So now it is 101. Okay, let us first make all the 0. So sum 0 carry 1, then 0 0 1, sum 1 carry 1, 0 1 0, sum 1 carry 0, 0 1 1, sum 0 carry 1, 1 0 0, sum 1 carry 0, 1 0 1, sum 0 carry 1, 1 1 0, sum 0 carry 1, 1 1 1, sum 1 carry 1. So it satisfies the truth table. It validates the truth table, hence the circuit is done. So this is the full header using two half headers. You can see the half headers inside this. Inside this you can see this is the half header circuit. Here also you can test whether this half header is okay or not. Similarly for this half header also you can see this is your half header. Okay. So that's all in the MULTISIM. Now the same we'll do it in Xilinx. So this is your Xilinx. In this Xilinx again, while doing the VHDL code, first we'll go the step 1, file, new project. So you need to create a folder, that is the project name. So here I am giving it as full header underscore half header, that means full header using half header. So then you can give the description here, full header, so using two half header and one organ. So the top level source here should be HDL. Then click next. So as I mentioned in my previous lecture, that this wizard is for the hardware setting, and since we are not going to connect any hardware, so this wizard does not have any meaning for the time being, so we will not do anything in this. Simply click next and it will give you the summary of the project, then finished. So after that, this is the project and this is the hardware that is already there, but we have not set it. So now we need the second step, we need to add a source file for the VHDL program. So right click on it, click on the new source, you will get this wizard. Here you click on the VHDL module and give a file name. As I mentioned earlier, this file name will be the file name for the VHDL program with the extension .vhd. Along with this same file name will be the name of the entity for the VHDL program. So here I am giving the file name as a full header underscore using underscore say half header. Okay, done it to the project. Next is the entity or the ports, different ports under the entity. So as you see, the entity name is the same as that I have given for the file name, full header using half header. Architectural name is behavioral, you can change it. You can change this name or let it be behavioral. So now the ports are A as an input. So here you give ports are A as an input, ports B as an input, port C as an input, and say sum as an output, then carry as an output. So then next, this is the summary of the entity that being declared. Finished. So this is the summary of the project actually, entire project, and here is the VHDL code, and this part is the command, as I mentioned earlier also, that the comment is showing green here, and this 2 hyphen is the command for the commenting. Anywhere if you type 2 hyphen and say like this, it becomes this comment. Okay. And the program, for the program, VHDL program, as I have already mentioned in my previous class, this first step is the library declaration, and the default library, that is the IEEE library, comes automatically. You need not to type. And for the basic programs, the IEEE library is sufficient. And next step is the entity declaration. It is already done in the port declaration. So entity, as I have given the name, file name, as I mentioned, that the same file name will be the name of the entity. Entity is the keyword, and any keyword here in VHDL you will see it as a blue. So entity is your keyword, then this is the name of the entity, and is also a keyword. After that, whatever be the ports that you have declared, that keyword is port A, B, C are in and comes under the STD logic, standard logic, under the library IEEE .stdlogic _1164, which is the version, and all means all the libraries included inside the IEEE are imported in this particular program. Sum and carry are the outputs. So this port, first bracket, all these ports, input and outputs, then the first bracket close, and semicolon, terminate the given statement, and here the entity gets ended here. So end the name of the entity, then semicolon. Okay. So once this entity declaration is done, now here our objective is to design the full header using 2 half headers. So this half header is a component here, and OR gate is a component here. So here we'll do the that is what is called the structural modeling. So that means structural modeling means we'll do the modeling as per the given structure. That is, in this given structure there are 2 half headers, same component repeated twice, another component OR gate. So therefore you have to import those components that are being required for the structural modeling. So although there are 2 half header, but you need to import only 1 half header, and as many as time required, that many times you can utilize here. So what to do? Go to this top level source. As I have mentioned earlier, that the top level source always being represented by this 3 squares in a triangular fashion, and with a green at the top representing the top level source. So just right click on this top level source, new source, then you put some name for the half header, say, and just put half. Okay, half means say a half header. So that is also a VHDL module. Then next, add to the project is checked. So now I'll write the port, give the ports for the half headers. Say A is input, B is input, say S is my output, sum output, and say carry is my carry output. So sum and carry are out. Okay, next, finish. So this is the half header programs which will be incorporated here. I will show you. Let us finish this half header program first. So half header program already we did in our previous lectures. So this is your library part, entity declared, then architecture body, and within the begin we'll start with a process statement. So what to process? The inputs A, B, then process begins here. After the begin, just the process is nothing but sum is assigned with A XOR B, and carry is assigned with A and B. So, a process ended here, end process, and the architecture body is ended here, that is name of the architecture is behavioral, end behavior. So, that is all. This program is done for the half header. What it is, the following files have been modified to save all modified. Okay. So half header part is done. Then one OR gate is also required. So again, right click on the top level source, new source. So I need one OR gate. So giving the name as OR gate. This is also VHDL module. So you see this same project. Yes. Next. For a 2 input OR gate, so A, B, and say Y as an output. So next, finish. So let us finish this OR gate part also, like previous one. Entity, library entity, then architecture behavioral of OR gate. Behavioral is the name of the architecture. You can give the different name as well. So then begin, again process statement. Process within bracket A comma B, then process begin here, and Y, that is the output, is assigned with A or B. Then process ended here, end process, and then end behavior. So the OR gate part is also done. Now go to the main program, that is the full header using half header program. So this is the full header using half header program. Okay. So before beginning the architecture here, this is the architecture declared here for the full header using half header. Before begin, you have to declare the component that are going to use. So for declaring the component, here the keyword or the syntax is component. Component exactly as it is being defined in the component, you have to define. So therefore component, name of the component, so half header, for half header I have given half. So better you copy from this half till end I am copying. So it should be exactly same as it is defined in the sub program. This is what is called sub program or component program. Okay. So that is why I have directly copied, copy from here and will paste it here. So you see this component half, the name of the component half is that exactly same port you have to define, and in the component, in component. Okay. So the half header component is being declared in this main program. Similarly, for the OR gate, again go to the OR gate program. So from our this entity name till end I am copying and paste it here. So component OR gate, because it has to be same, exactly same, and everything here whatever you have declared here as exactly same has to be declared here. So therefore I have copy and paste. So component OR gate is this, and then in the component. So component declaration part is done. Once the component is done, then what next is to be done here is, as you can see in this circuit, A and B are applied directly as an input to the first half header, and the sum out of the first half header is acting as an input to the second half header. So here this sum out of the first half header is behaving as an input to the second half header. So therefore it is input output. Better we need to define it as a signal here. let it be S1. Similarly, the carry out is the output of the first half header and input to the OR gate. So therefore, this is an output also as an input. So we will define it as a signal. So let it be C1. Similarly, the carry out of the second half header is an input to the OR gate. So this is an output of the half header and an input to the OR gate. So therefore, this is also a signal. So therefore, let us define three signals S1, C1, C2, where S1 is the sum out of the first, C1 is the carry out of the first, and C2 is the carry out of the second half header. So let us define it as a signal. So for defining signal, the keyword is signal. Okay. So signal semicolon. Sorry, signal, then the name of the signal. So I will give it as S1, C1, C2. So S1, comma C1, comma C2. So colon. The signal is also will define it as std logic. So std underscore logic. Okay. So the signal declaration is done. So once the signal declaration done, then the main architecture part will be begin here. So since it is a structural modeling, there is no need of the declaring the process statement. So directly we can begin. So the architecture here is structural. So you need to define the structure like this. Okay. So there are three components. One is half header 1, half header 2, and OR gate. Okay. So therefore, we will label it. So let it be U1, U2, U3. Okay. So say U1 is my half header 1, U2 is my half header 2, U3 is my OR gate. Okay. So what will be U1? U1 is my half header. So what is the name of the component? Half. So I'll give it as exactly same half here. Then port map. Port map is the keyword for connecting. Port space map is the keyword or the syntax for connecting. So the within bracket you need to provide the arguments or the input output. What are the inputs of the first half header according to my structure? The external A input, external B input, some output here I have defined it as a signal S1, and carry output I have defined it as a signal C1. So therefore it will be A as input, B as an input, because as you see the half header there are two input, two outputs, exactly same number of argument you have to provide here. So S1 is my signal output, that is the sum output, and C1 is my signal which is being defined for the carry. Okay. So this part is done. Similarly, second half header, I mean U2 is my second half header. So again half port map. Now in the second half header, as you see here, the signal S1 is the A input, C is my external C is my B input, external sum out is my sum output, C2 is my carry output. So therefore S1 as an A input, then C as an external B input, then ultimate output sum is my sum output, this SUM is the sum out as declared here, and C2 is the carry out of the second half header. Okay. So that's done. Similarly, third is my OR gate. So U3 is my OR gate. So OR gate port map within bracket. So OR gate, there are two inputs, one outputs. So according to my structure, the OR gate inputs are C1 and C2, and the output is final carry. So C1 as one input, C2 as another input, and final carry as my output, carry out. Okay, so it's done. So that's all only, this much only. Okay, so the structural behavioral part or structural modeling part is done. So let's save it. Now you see, this was my main top level program, and under which you see U1 is half header, U2 is the half header, U3 is the OR gate. So it is showing in a hierarchical order. Now let us see, let us check the syntax for each. So for the half header, first I am checking the syntax. The check syntax for the half header is going on. This is the half header program. Okay. So check syntax successfully, completed successfully. So half header, this and this are same only, no need to repeat twice. Then check the syntax for the OR gate. This is your OR gate program. So currently this check syntax is going on for checking the syntax of this OR gate. Okay. So check syntax completed successfully, that means there is no syntax error in this OR gate. Now let us check the syntax for this full header main program. This is the main program. Okay, check syntax going on for this main program. So check syntax completed successfully, that means there is no syntax error in this program. So that's done for the structural modeling of half header using full header using two half header. Next step is applying the test bench. Again, go to the simulation. This is your top level source. Now I am going to add the test bench for the top level source only. I will not check the simulate the logic for this half header and OR gate. Directly will check the logic or simulate the logic for the full header. So right click on it, new source, say let it be full header underscore tbw, just the file name for the test bench, and you need to click on this VHDL test bench, then add to the project. Next. So you see these are the three, so by default it will go to the top level source. Yes, this is my top level source, and I am adding the test bench waveform file for this. So it is by default selected. If not, you select it. Then next, this is the summary, finish. Next there will be a VHDL program will be there. Yes, this is the VHDL program for the test bench waveform. Again, this is the library part, entity part, architecture, and component is being declared since it is also a structural program. These are the inputs, outputs. Now as I mentioned earlier also that this is my behavior combinational logic, so I will not use the system clock, so I will delete this clock part. Okay, begin. Here instantiation is being done, and since I am not using the clock, so this part also being deleted. Okay, so as we did in the previous lecture, so here also, so let it we'll do the program for the test bench waveform. So steam process 1, so let it be wait for 100 nanoseconds since there is no clock. Delete this. Then say A is assigned with not A. then this line is also not right. This is just a command line. Then say wait for say 50 nanosecond. End process. Similarly, for B, say steam process 2. Okay. So now let it be wait for 200 nanosecond. Now it is B. This timing I am giving arbitrarily, and say let it be 100 nanosecond. Then you are in a process. Then for C, so let it be steam process 3. Now say it is 300 nanosecond. It is C. So wait for 150 nanosecond end process. So that's all. Save it. Then let us check the syntax, behavioral check syntax for this baseband waveform program. So check syntax completed successfully, so it's done. Then as you see, this is these are the components. This is the main program, and this is the test bench waveform associated with this a full header using half header. Now simulate the behavioral modeling. The simulation is going on. Okay, it will open a new window. Yes. Okay, so this is the test bench waveform with this marker that you can see here. Suppose at this point, so input 1 1 0, so sum out carry 1. You can check here, say 1 0 0, so sum is 1, carry is 0. 0 0 0 0 0, 1 0 0 1 0, say 0 1 0 1 0, 0 1 1 0 1, 1 1 1 1 1, 1 0 1 0 1, 0 0 1 1 0. So like that is validating. So that means it is validating the truth table. Okay, so let us close it. That means your simulation is done and logic is tested. Next, again go to the implementation. This is your top level source. Now I will generate the RTL schematic. RTL schematic is running. For the main program, this is going on. Okay, so let us start with the top level schematic. So this is the top level schematic of the designed logic. This 3 ABC are input, carry and sum are output. If you double click on it, you will see this is your half header, this is another half header, this is all good. If you double click on it, you will see the half header circuit. This is your AND gate, this is your XOR gate. Similarly, another half header, if you double click on it, AND gate, XOR gate, and if you double click on it, this is an OR gate. Okay. also you can see the technological schematic. So this is the technological schematic. This is your carry part, A, B, A, C, B, C all together. This is your sum part. Okay. So as in the truth table, as in the circuit that we designed, two half header, one OR gate, exactly this circuit is being generated here. So that is the structural modeling. Structural modeling means you are exactly designing the structure that is required. This structure is required here. Okay. So this is how we do the structural modeling. Okay, and it is being done for the structural modeling of full header using two half header. Okay, so that's all. Thank you.